At the top of page 4 for 9.1, we're going to look at some of the Practice Plus problems that you'll encounter in the problem set for homework. And Practice Plus, as always, is combining a couple different skills together. Let's read the instructions. For which values of x is each radical expression a real number? Express your answer as an inequality or write all real numbers. So what we're doing here is we want to make sure that whatever we're taking the radical of what's under, we want to make sure that the radical is a real number. So we have to make sure what's underneath is a positive number. Okay? In other words, we want the radicand, sorry, spelling error, radicand, what's underneath, to be greater than or equal to 0. So that's what you're going to do, is take that radicand and set it greater than or equal to 0. So in this case, what's underneath the radical is x minus 3. So to make sure that we get a real number from this radical expression, we take x minus 3 and make it greater than or equal to 0. We make sure that it's going to be positive so that we can take the square root of it. And then we solve the inequality. Now this is Math 60 stuff. We solve that inequality to find out what our possible values for x are. We add 3 to both sides. We get x is greater than or equal to 3. So our answer is, as long as our x values are greater than or equal to 3, we're going to be able to find the radical of it. Makes the radical expression a real number. Let's look at number 82. This time we have x squared plus 3 underneath the radical. And remember, as tempting as it is to think, oh, well, that's just the radical of x squared plus separate the radical of 3, or the square root of 3, you cannot separate addition and subtraction underneath a radical, so it has to stay the same, stay together. So we do the same thing as we did before. To ensure that the radical is going to be a real number, we have to make sure that what's underneath is positive. So we want to take x squared plus 3 and guarantee that it's going to be greater than or equal to 0. In this case, when you solve for x, or begin solving for x, you'll get a statement of x squared is greater than or equal to negative 3. But let's analyze this a little bit. When you have x squared greater than or equal to negative 3, this is a true statement. And the reason is because anytime you multiply something times itself, x times x, that answer, whether x is negative or positive, if x is positive, x squared is positive, because a positive times a positive is positive. If x is negative, x squared is positive. And positive numbers are going to be all greater than negative 3. So far, if you put a positive number in, you're going to get a positive answer, and that makes this a true statement. As if you put a negative number in, you get a positive answer, and that makes this a true statement. Okay? If you put 0 in, that's the only other possibility, then x squared is 0, and 0 is still greater than or equal to negative 3. It's still to the right of negative 3 on the number line. So no matter what number you put in, this will be a true statement. No matter what number you put in here, you can take the square root of it. It will be a real number. So this is a situation where it's all real numbers. As soon as you get a true statement from your solving, then you can say it's all real numbers. So take a moment to copy that, talk it through, note any questions you might have, bring those to class, and we're actually going to have you try this application exercise. So we'll read it together and see what you can do. Remember that the application exercises are sometimes easier than the Practice Plus. It's just taking what we've been practicing, in this case, finding the root of something, and putting it to a real life sort of situation or model. So number 86 says the formula V equals square root of 2.5r, both the 2.5 and the r underneath the square root. Models the maximum safe speed, v, in miles per hour, at which a car can travel on a curved road with radius of curvature r in feet. A highway crew measures the radius of curvature at an exit ramp on a highway as 360 feet. What is the maximum safe speed? I'm just going to take a moment to kind of break that apart for you. If you would like to try this completely on your own, pause the video now. If you'd like to hear me talk through a little bit and then try the answer on your own, keep watching before you pause it. So the first part explains what the V and the R mean. Here's our model, here's our equation, which means when they give us an equation, it's time for a little happy dance because all we're going to have to do is just plug something into it. So models the safe speed V, so all we have to do is come up with the, so all we have to do is see what V and R are. Model safe speed V, miles per hour. The R is the radius of curvature on the road. So now look at what they're giving us. A highway crew measures the radius of curvature at an exit ramp on the highway is 360 feet. What's the maximum safe speed? So as you look at this, the V here in the formula is the maximum safe speed, and the R here in the formula is the radius of curvature. So once you know that, you can look at what they give you here. They want to know what is the maximum safe speed, so we're trying to find V when what? When the radius of curvature is 360, so that's our R value. So find V when R equals 360. So that you're going to plug R in to the formula and solve this to find V, and you'll have to use your knowledge of radicals at that point. So now would be a good time to pause the video to try to find the answer on your own, and then we'll come back with what that answer should be in a moment. Okay, you should get a value of 30 as your final answer, and in this case it's a speed, so it's 30 miles per hour. All right, that takes you, and I'm happy to show that one in class. If you have questions, please don't hesitate to ask. That's what class time is for. That's what I'm here for. And then you'll have some review and some preview exercises to finish up 9.1.